Emostel.
Yeah, you're welcome to this video, and this is Emmanuel Kadri of Emostel Academy. Right, this video is just a continuation of where we stopped the other time. Now this time around, talking about algebraic equations, we want to just play with a few more examples just to promote clarity. All right, there we go. Let's assume you have something like this: 2x minus 7 is equal to 1. 2x minus 7 equals 1. And then the question says, find x. All right. So in this kind of algebraic equation, sorry, I forgot something. I never told you the reason why you cannot add this thing. You cannot add them because they are not like terms. You get me? You can't add them because they are not like terms. One of the laws in algebra is that only terms that are alike can add or subtract. The law that governs addition and subtraction is different from the laws that govern multiplication and division. So this is one of the things I tried to establish in the previous video, but you will see more of it, and so you will understand better. All right, so here we have 2x minus 7 is equal to 1. And say find x. Some people make the mistake by saying, oh, 2x minus 7. So we just say 2x minus 7, then that will give us minus 5 or whatever. Or maybe it is even plus. Say 2x plus 7, that is supposed to give us 9x. No, it is an error. You don't do that. The reason why you don't do that is that it's just an assumption by saying, okay, $2. Okay, $2 plus ordinary 7. All right? Or you are saying 2 biros or pen. Okay, we have 2 pens plus 7 monkeys. Oh, now this is a term on its own. This is another term. But are they like terms? No, they are not like terms because they don't have anything in common. We have 2 pens. 2 pens cannot be added to 7 monkeys to give us any results in mathematics. You can only have them staying like that on their own. 2 pens on its own, 7 monkeys on its own. And they will remain like that forever. They cannot add or subtract to give us a result because they are not the same. So only terms that are the same or that look alike can add or subtract. So I can easily say 2 pens plus 7 pens then equals what? 9 pens. All right? I can say 5 monkeys minus 3 monkeys give us what? 2 monkeys. You get that? Okay? So, because they are like terms, because they are the same, they can easily add or subtract. They look alike. It is only when they don't look alike they cannot add or subtract. Look at this one here, 2x and ordinary 7. This is a 2 that has an x, but this one is a 7 that has nothing. They don't look alike. They can remain like this forever and nothing will happen. They will never be able to add or subtract under any circumstance. Do you understand that? So now moving forward, so now that we know the reason why they cannot add or subtract, we can move from here. Let me just change this one back to minus. So 2x minus 7 is equal to 1. And then the question says, find x. How do we do that? All right, so I told you earlier, the next thing you do, the very first thing you do is to, collect like terms. Collect what? Like terms. Collecting like terms means you are bringing together terms that look alike. So you have this as 2x minus 7. You try to move this minus 7. You try to move it to the other side. Okay, so we have 2x equals 1. It was minus 7 before. By the time you get to the other side, it becomes plus 7. It was negative here, it gets to the other side and becomes positive. Okay, so we have 2x is equal to 1 plus 7 gives us 8. And so just like what we did earlier, we have 2x plus 2x is equal to 8. Then how do we find x? Method 1. Method 1 is to assume that we have 2 times x is equal to 8. All right, so if you assume 2 times x equal to 8, all right, so x will be equal to 8 divided by 2, because trying to move this 2 to the other side, 2 is working with this multiplication, the x works with this multiplication. Like I told you, the rules that govern addition and subtraction is different from that which govern multiplication and division. In terms of multiplication, both of them own this. But in terms of addition and subtraction, if you have 2 terms, let me just say, let me take you back a little bit. We are coming back here. Just quick explanation of something. If I say something like 2, let's say minus 3x, okay, 2 minus 3x plus 5 is equal to 1. Let's just put it this way. 2 minus 3x, let's say minus 5 is equal to 1. Something like this. I just want to show you something. All right? So, I may decide that in the process of collecting terms, I put these things together first on one side. Okay? Let me put something like plus x. Okay, good. Just check this out. I want to explain this, but I want you to just check this out first. I'm sorry for the diversion, but it is necessary. Okay? So, just keep your focus here. And then, we need to collect like terms here. Collect like terms. Okay? Now, to collect like terms means we are bringing terms that look alike all together into one side. All right? So, I'm interested in this guy. I'm interested in the x terms. This is the x term. This is another x term, okay? I'm interested. If you notice that if I want to circle the term, I always circle them with the sign in front. But when it comes to this multiplication, I don't do that. The reason is that when it comes to addition and subtraction, the sign that comes before a number or a term belongs to that term alone. All right? So this plus, this minus sign that separates this term and this term, yes, it's good. It separates them. But the minus sign actually belongs to the number that follows it, which is 3x. Here, the minus sign also here, although separates this term from this term, but it belongs to this 5. Also, the plus sign that separates 1 and x is fine. It's good to separate, fine, okay? But then the plus sign belongs to x. But in the case of multiplication and division, it's not like that. Do you get that? So, whichever one I choose to send to the other side, they will go there to divide. If I choose to send x to the other side, so we have 2 equals what? 8 divided by x. It's valid. If I send 2 to the other side, we say x is equal to 8 divided by 2. Whatever I send to the other side go in form of what? Well, it goes in form of division. All right? Goes in form of division. Because both of them they are both entitled to this operation, to this sign. But in this case, only the number that follows the minus or the plus is entitled to the sign. This is not entitled to it. You get that? Then you may be asking me, so what is 2 entitled to? It is entitled to a sign actually. The sign is what? Is plus. It's an invisible plus. In mathematics, whenever the first number is positive, you don't have to write the plus, but you know in your mind that there is a plus sign there, which says it is positive. But when the very first number in a term is negative, then you must know that that negative sign must be indicated. It must be indicated, so everyone knows that it is negative. So if this happens to be a negative 2, I have to put it there compulsorily. But if it is a positive 2, I don't need to put it there, but I know in my mind that there is a plus sign there. You get that? You get that? So if we are moving all these numbers, we'll know that 2 is positive. So the number that is the sign assigned to it that is entitled to is what? An invisible plus. So we keep that in mind while we are moving. So now, moving this, we have, I want to keep this x because this x is negative. So this term is negative. I am going to repeat the negative term, minus 3x. You get that? And then I just want all the x terms to the left and all the other terms to the right. That's what I want to achieve. Okay? Now, this is also another x term. So I bring it to here, to this side. So we have this one going here. So this minus 3x, and then it was a positive x before. By the time it moves to the other side, it becomes what? Negative x. Now that I'm done moving all the x terms, the next agenda is to move all the constant terms. That is, the numbers that don't have any variable attached to them. Okay, so we do that. They don't have any letter attached to them. So this is 1, right? We have 1. This is minus 5. It becomes plus 5 by the time it moves to the other side. Okay, and then this is positive 2. By the time we throw it to the other side, it becomes negative 2. Are you feeling me? So now we have successfully collected all the terms, all x terms to one side, all constant terms to the other side. Okay, then minus 3x minus 3x means, in mathematics, it means I am owing 3x and I am owing another 3x. All together, it means that I owe what? Sorry, I'm owing 3x and I'm owing another 3x. If I owe 3x and I owe another 3x, then it means I owe 4x. All right? So just know that what? Plus means to have and minus means to owe. So if you owe, you have to pay. In the process of paying, a value keeps decreasing. You get that? But if you have, okay, the value keep increasing. If you get another one again, then you increase. But if you owe, okay, if you keep owing, then the value keep depreciating and all that. So just get that in your mind and understand it somehow, you know, how best you can picture it. Okay, but just know that overall, plus means to have, minus means to owe. So if I owe 3x and I owe another 1x, then it means I'm owing what? 4x altogether, right? So minus 3x means I owe 4x. Minus means owe, plus means have, okay? Now, in this case, I have 1 and I still have another 5. Altogether, I'm having 6. But if I'm having 6 but owing 2 and I paid it 2, then it means that I will be left with what? I will be left with what? 4. Good. So now I'm being left with 4. Okay. So we've settled this side and we've settled this side. So the normal tradition comes to play. And that is exactly what I'm about to do here. So let me just do it here first. So we have, to settle the two sides, you have 2 methods. I wrote method 1. So let me continue with where I stopped from here. Then I would use the other side as method 2. So method 1 is that is to consider 2 and x as multiplying each other. So 2 times x is equal to 8. So when this 2 moves to the other side, it goes in form of division. Remember that the both of them are entitled to this multiplication. So we have, so we have x equals 8 divided by 2, and x becomes what? When you divide 8 by 2, you get what? 4. And that is the answer. All right? The other method would have been, let me use this for the second method. The second method is to divide both sides by minus 4. Okay? Minus 4x is equal to 4. I want to keep only x. I want to, and then to send this minus 4 to the other side. I'm trying to keep x alone and then send minus 4 to the other side. So what do I do? So I will divide both sides by minus 4. So I will have minus 4x divided by minus 4 is equal to 4 divided by minus 4. And then another law comes into place. I'm loving this. So the more we solve more questions, we come across more laws. That is just the ideology. We understand that many of you already know how to add and subtract and all that, but then you don't know the laws that govern them. And then this lack of knowledge of the law makes it complicated for students to understand how to handle these numbers and then make them to get the wrong answers most often. So, but the time, most of the time rather. So, but the moment you are familiar with the laws and also all the methods involved, then you are good to go. Math is so easy. All right. So back. Now we have the law. Another law here says minus times minus is equal to plus. Plus times plus is still equal to plus. Minus times plus equals minus, and plus times minus equals minus. Right? You don't need to cram it. You don't need to memorize all this. Just understand something, that when the same signs multiply each other, same sign, the result is always what? Plus. But when different signs multiply, the result is always minus. All right? So this is the result, this is the product of what? Of same, is a product of same signs. Okay? Why this is a product of what? Different signs. You get that? So that's that. All right, so whenever the same sign multiply each other, the result is always positive. When different signs multiply each other, the result is always negative. And then, if you change all of this multiplication sign, you change them to division, you still get the same result. Which means that as it works for multiplication, it also works for division. Which means if I decided to say minus divided by minus, I'll get what? Plus. Plus divided by plus, I'll still get plus. Minus divided by plus, I'll get minus. And plus divided by minus, I will get what? Minus. So as it applies to multiplication, it also applies to division. You still get the same result. So we are going to use the division part of it now. All right. So minus divided by minus, they cancel out to become positive. All right. But plus, I told you when a number is alone without any sign in front of it, okay, we just know in our mind that there is a negative, there is a positive sign attached to it. Okay, so we assume this one to be like an invisible plus because it's a positive number, and then this is a negative number. We can't do without indicating the minus. So plus divided by minus gives us what? Minus. All right, sorry. Let me just repeat. Just let me deal with this. Okay, negative, minus divided by minus is positive. They cancel out to become positive. 4 divided by 4, that's 1, okay? So this x is remaining, so we say x is equal to, now, plus divided by minus, the answer is what? Minus, because they are different signs. The result will be negative. When they are the same sign, the result will be positive. So 4 divided by 4 gives us 1. So x is equal to minus 1 in this case. While x is equal to 4. Wow, we solved we did 2 examples in one. All right, so that's beautiful. So if there is any part of this you don't understand, you can always rewind and then play again. And if you rewind and play severally and you still don't get anything, then you can just contact us through the phone number on WhatsApp and then through the email address. Okay, so that is the end of this video. I hope you've learned a lot. In the next video, we are going to be dealing with more examples. Then see you then. Bye.